Good evening. Welcome to the Landhammer stream. It is Wednesday, hump day. Glad to have you here. Got some more BGP going on tonight. And we are going to talk about a few things. I apologize. I was unable to stream last night due to the fact that I just had a lot of work to do. Had a couple of changes, had a change window, and several F5 load balancer changes that were scheduled. So, anyway, I am probably not ready to do this lab tonight in terms of study and where I'm at on the videos and my reading. But we're just going to go ahead anyway. I felt like I needed to go ahead and do a lab. So we're going to attempt one. I did learn something cool that I want to share if any of you guys or gals are Safari users. I thought it was really cool. I Again, it's still some of the same features of using the full screen. So if you do, let's say you do, for example, go to cisco.com. And it's probably just sitting here in plain sight the whole time. So let's say I want to compare a couple of different commands. We're going to go support. We're going to go network software. Yeah, let's say we do 15.6. And I want to compare, I want to duplicate this screen. So I'm going to do a new tab. And I'm going to do, for example, master index here. And over here, I'm going to click another link. Let's say release notes. And then what I could do is I could pull this tab off. I can go to full screen, which is pretty cool. And then I can go to this one and I can do full screen, which, I love doing these full screens. I can combine these like this, which I already knew about, but what I did not know is that you can actually, let's do a better comparison here. This release notes. Okay, let's open this document, for example. And then this document, let's go to Cisco iOS Master Command. So let's say there's a couple of applications of this that I've used, but you can actually move this line, which I did not know you could do until I think yesterday, which is awesome. So I don't know if you can do this in Windows. I know you can tile screens like this. Of course, this is full screen mode, so I can move this around wherever I want. Man, I just thought, wow, I wish I'd have known about this because there's a lot of functions where I need to share a screen and I need to do a side by side. And that just arranges it so neatly. I love that. So anyway, that's a cool new feature. You'll be seeing it here on the stream. Halo 3 is 10 years old. This was the first game that got me really into sort of multiplayer gaming as an adult. Just some hard work there from Halo 3. No meat chunks today because, again, the last 2 days have been very busy. I did share one last night on Twitter. If you follow me on Twitter, there was Narbik did and I'm not going to try to say his last name. I know how it's spelled, but anyway, he does the Narbik boot camps, which I'm considering going to. I'm not sure when. I've had a lot of discussion about this in Router Gods and INE group about, when is the best time to attend a boot camp, and I'll probably do a vlog about that at another day after I get into some more thought. In fact, let's put that in our bucket of future vlog topics. Yeah, boot camps. So I'm really consider doing that, but he did a free. You see it on Twitter. He did a free, video series on MPLS VPN, and I'm not anywhere near that in my studies. So I thought it'd just be way over my head, but it was Narvik. I mean, who's not going to attend a free session from Narvik? And a lot of people are saying his boot camp is probably the best, and he knows CCIE route switch in and out like nobody's business. And the way he explained it was so well. So if you haven't watched that, even if you're not in that part of your studies, I'd encourage you to watch those videos. Those are the VODs of the session that was done on the Cisco Learning Network yesterday. Other than that, I don't have any meat chunks to share because, like I said, I've been very busy. And whip cracking. Another thing that I saw that's kind of cool is this command. So you do show BGP all summary. You do show BGP summary a lot. Another engineer was saying use this command. So we're going to try that today. This is a much more compact version of the command, which we're going to try out. And then the lab that is on scheduled for today is iBGP route reflection. Now, I know what this is. I know what the feature is supposed to do. I know some of the use cases. I've gotten to part of that in my reading of BGP, Practical BGP book. I'm in the enterprise section of the book right now, all the uses of BGP in the enterprise, why you would use iBGP in your core, for example. Man, such an important chapter to read. I wish I'd have read this years ago. Great book so far, Practical BGP. But I'm in that section and I've read probably half of that chapter, so I know what this is for, but I have not read any material yet on how to actually configure it. But what the heck, we're going to try it anyway. And I left my fan off. I need to turn it on real quick. It's Florida, it's hot. Just a moment, please. Okay, that is done. Something else I will share with the stream as well that it's not really stream relevant, but you might see me bouncing up and down sometimes. That's not from sheer joy or any other emotion, but that is because I have switched back to using a medicine ball chair as a chair. I don't know if you have ever seen anyone that does this. Um, that's not what I had in mind. If you just do a search on that, you'll see people. Okay, so yeah, this is basically, it's blue, and it basically looks like this. That's pretty much exactly what it looks like. I used a chair like this for a couple of years in my last, well, in this job when I was in the office, when I was on premise, and it was great. Since I moved here, when I moved to Orlando and started working remote, continued to use it, and I don't know, just over time, for some reason, I switched back to a regular chair, which you're probably seeing here on the stream, but I've started to have some back issues, and that's due to posture. Take care of your posture, folks, your back posture. Um, I can give you, I won't go into details now, but I can just tell you, and that's a good vlog topic to discuss at some point in detail. But, you know, I have issues today because of 20 years of just sitting like this. So, anyway, I'm on a ball chair now, and or a medicine ball. And if you see me move around, sometimes I will bounce when I sit back on this thing. It's kind of weird, but it is great. Um, anyway, I'm going to put that as a future blog topic. But let's get on to this lab. So, um, again, uh, this is probably going to be a stumbly little lab just due to the fact that, I don't really know what I'm doing here. I know in principle what it's for, but I've never configured it. So here we go. Let's just get it out there. This is the requirements. I will type those in a moment. This is going to be the configs, and I've already loaded the topology. Again, in disclaimer time, I'm using INE workbook. These labs are not on my design. You will not see the INE materials on the stream. You're just going to see me kind of stumbling through them, especially on this one, probably. But anyway, these last 4 or 5 labs have required a completely new topology to be loaded. And I anticipate that's going to continue to be the case. So I've already loaded up this topology called iBGP route reflection. I have no idea what's in this topology, but we're just going to go with it. So these are the requirements here. And And I'm not sure what just happened to the stream there, guys. Sorry about that. It said that it stopped and then continued, so I'm not sure what the deal is there. The stream says it's running now. So anyway, we will carry on. Sorry about that. Must be a lot of people on Netflix tonight. So we're gonna do router 1 is gonna do iBGP peerings with everyone else. And then Ties L0 prefixes of all AS100 devices into BGP. Okay, makes sense. But we're not going to have full mesh, apparently. Apparently, router 1 is going to peer with everyone else. So let's just draw this out, right? So we're going to have let's don't do that. I have not really been using this sword soft that much. So let's see what we're going to do here. Let's see a line here. So we've got, delete that. That's not what I wanted you to do. That's fine. So yeah, we've got 1 through 8 going to be AS100. And then router 1 is going to peer with everybody else. So we're going to have, it looks like 1 is going to be our reflector, right? Gonna be a little spider here. There we go. So he's going to peer with everyone, and then he's going to do a he's probably going to be our route reflector. Okay, I'm just taking a moment here to check the stream. The stream health says it's good. Just checking the dashboard again here, guys. Okay, yeah, we're streaming. Good deal. So these are the route reflectors, and then what are our other requirements here? Configure iBGP peerings R7 and R9. R8 and R10 using directly connected links. Makes sense? R9, R10, RN, AS 54. Okay, so these are going to be, let's draw this out here. Actually, we'll just AS 54. Let's see, both of those routers, right? Yes, so these are both in AS 54 here. Routers 9 and router 10. And let's see. Advertise R7, R9 link into EIGRP on router 7. That makes sense. That's our reachability to, well, and then advertise R8, R10 link, EIGRP on router 8. Ensure full reachability. to all, to loopback 0. Prefixes from all internal. And then to all prefixes learned from S54. From internal devices. Okay, so the distinct feature here is that we are doing, we got AS100, and let's make that green. AS54, and we have R1 is only going to be the only one peered in AS100. So R3 will not be able to talk to R2 in BGP, nor R7 in BGP. So what we would expect is that in these eBGP peerings, and let's put that here, and here, that it's going to exchange, these links have to go into iGRP, right? This link here has to go into iGRP. Then everyone else will have reachability to the routes advertised by router 9 and router 10 from AS54. So all this I know how to do except how to make this route reflection work. So what I'm going to do is just search for the documentation on that. And I did a little searching and did not find anything. Let me just search again, make sure I didn't miss it. I had a window open. I want to see if I can find the documentation again before I do a Google search, which I always feel is kind of like cheating. Actually, I finally made a shortcut to this. I know how to get here. I don't need to search for it every time. So I noticed that if I go under products, iOS and XOS software, iOS 15M, I've noticed that if I go under the configuration guides for BGP, there's some stuff, but there's really not a lot for what I would think there would be, right? Like, for example, if I do route, I see BGP using a diverse path route reflector and EVPN route reflector support. I see that there. I don't see a configuration guide. Now, if I go under overview, and I've already done this search, but I'm going to do it again on stream. It just talks again about L2 VPNs. You know, again, at this stage, we're not too concerned about that. If I could do configuring a basic route reflector client, yeah, again, it's not really telling me here how to do it. Maybe there's another wording. I'm just going to scan through here. Maybe there's another document that sort of indicates having to do with iBGP or peering or something like that. So we'll just kind of scan through here. All right, AS-BGP neighbor policy, BGP dynamic neighbors. Internal BGP features. Let's see if this, here we go. However, this card does not scale well in the many, instead of configure to configure route reflector, yes. This is what we have. We've got eBGP, then we've got iBGP here, cloud, and we've got okay, that is a fully meshed. Yeah, here's a route reflector. This is what we're about to do. Okay, this is where you have partially meshed autonomous system. Okay, we're not going to read through all this on stream. But does it have, oh, here we go. Configuring a route reflector. Okay, this is what we want. Figures the local router as a BGP route reflector and the specified neighbor as a client. If there's one, plus there's more than one route reflector, either cluster ID. Okay, in this case, in this lab, we're only going to have one. By default, the clients of a route reflector are not required to be fully meshed. The routes from a client are reflected to other clients. Okay, I'm not going to turn this off, but I do understand that in this particular topology, we are fully meshed. And we could use this command. We're going to try it, like at the end of the lab. I'm going to try it. So it looks like all we need to do, this is for using a route map. So what we're going to do is look up this command in the here's a BGP route reflector and the specified neighbor as a client, right? So let's look up this command here. That's all there is to it. This is pretty simple. Principle anyway. I could have went to my, that's okay. So let's go command reference. IP routing BGP. Neighbor. This is the only section I've really used up until now. Well, even now. Here we go, route reflector client. Neighbor, IP address, route reflector client. By default, all iBGP speakers must be fully meshed. When all the clients are disabled, local router is no longer a route reflector. If you use route reflectors, all iBGP speakers need not be fully meshed. Okay, yeah. A lot of other related commands. All right, so this is all we need. Does it have an example here? Yeah. So we're going to take this command and we're going to put it here. And then we're also going to play with this command. All right, so let's go back to our requirements and our configurations. All right, so we'll start with router 1 because router BGP 100. And he is going to neighbor with everyone else. So again, I think all we have to do is on router 1, we have to have, and why does that keep turning blue or green? On router 1, we have to have neighbor statements to each of these individual routers. And then on these routers, we just need a neighbor statement just to router 1. So what we'll do here is router BGP, we're going to say neighbor. Let's start with router 2. And what are we going to do? With everyone else, it doesn't say how to neighbor with them. But I'm assuming we'll use the loopbacks. Do we have reachability to the loopbacks? We need to check that first. No, I don't want to use iTerm. I miss you, iTerm, but I can't use you at the moment. 5, 6, 7, 8, 9, 10. Telnet, Varl. So show run section EIGRP. Okay, we're not currently. I guess that's what we're going to use BGP for. So we're going to have to use directly connected links, aren't we? That's fine. That's what the design is asking for, the requirements. So that is what we're going to do. So router 1 to router 2 would be through the tunnel interface. So neighbor 15.1.0.2, remote AS100. And then I'm assuming we have to do a separate neighbor route reflector client, right? So then let's do router to router 3.1.13.3. I want to type this out because I need practice on these commands that I'm still unfamiliar with. Okay, so that's router 3. Router 4 is going to connect via 1.146.4. Neighbor, router 5 is going to be via the tunnel interface. Neighbor 0 to 5, route reflector client. And neighbor router 6 is going to be 1.146.6. Neighbor router 7 is going to be, we'll go via router 3. I guess it doesn't matter particularly. Remote AS100. Okay, neighbor. Let's see, router 8 is the last one. I'm gonna go 58.8. We want to advertise our loopback, so we're going to say network 50.1.1.1. Okay. That looks, let's see, router 2, router 3, router 4, router 5, router 6, router 7, router 8. Okay. So now we have to go to each router. I know there are other things to configure, but I want to do the BGP part first. We're going to do this. And this is going to connect via the tunnel interface. And then we're going to do network statement. He is only going to appear with router 1. So we're going to do that on all these routers here. Router 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Okay, router 3, he is going to peer via 13.1, and he's going to advertise his loop back here. Router 4 is going to be 146. 146.1, he's going to advertise his loop back. Router 5 is also going to be 51.0.1. Wait a second. That's right, 0.1. Advertise his loop back at 5.5. Router 6 is going to be 146.1, 6.6. And we'll probably do this iBGP stuff before we do the eBGP, which I guess is just there for practice. Router 7 is going to be via 13.1. Yeah, that should work. 7.7. And then router 8 will be via 51.0.1. Yeah, 8.8. I'm assuming that's the route it will go. Let's double check that. See, that's the problem with not being able to use loopbacks. Let's go to router 8. Trace route. Yeah, okay, it goes across the tunnel. Just wanted to make sure. Okay, so that looks like router 1 through 8. Now let's look at our requirements again. Make sure there's no BGP running. None there. Amazing that they would ask me to check that. I'd hate to get to one router though and it be running on that router and blow up the whole thing. No assumptions being made here. Router 6 be 12. There. For good measure, let's just go ahead and check routers 9 and 10. Oh, that was routers 1 through 8. Interesting. This has got all kind of stuff on it. Although it said make sure no BGP running is on routers 1 through 8. Look, we got a route map here. We've got all kind of stuff. Do I blow it away? Look at that multi-hop. Yeah, I think I'll blow this stuff away. That could be an error. Like maybe it's safe. I don't know. I'm gonna blow it away. I'm gonna save what it had. Say no router BGP 54. Yeah. We are gonna clean that up. How about on here? This has it too. What is going on? All right, well, it looks like it's configured for this lab. I don't know what all this business is here. Okay. And this is iBGP stuff. So I think this part, at least this is a good phase to go ahead and implement what we have. So let's do that. It's a lab after all. Okay, it liked all those commands. Router 2. Now let's see if we get, well, let's just go ahead and put all this in here. Router 3. Router 4. 5. 3 more. 6. 7. And 8. All right, good deal. So what I would expect to see is neighbors coming up, which I do. 2, 3, 4, 5, 6, 7. And we're just waiting on 8. There we go. Okay, so theoretically, if we have iBGP running, we have route reflector running, route reflector clients, theoretically we should see all the loopback prefixes learned through iBGP. Let's see. None. Show IP route. What did I do wrong? Oh, it was still converging. So there we go. We have iBGP because we have 200. Let's look at show IPBGP. And what was our new command? We're trying to learn. Yeah, we'll put that over here. So let's check it out. Show BGP, show IPBGP sum. Okay, maybe that command. We get a lot of stuff in here, right? So what if we do show BGP all summary? I think that would be important if you had multiple address families in play, right? Instead of show IPBGP, you can do show BGP all summary. What if you do this plus exclude BGP and memory? Nice, look at that. So it takes out all this stuff and shows you pretty quickly. Nice. So we've got one prefix from each. So let's see if those are reflecting back to our other iBGP peers. Show BGP all sums. Okay, yeah, we've got one peer here, but we have learned all the loopbacks. Nice. And let's look at this. Known via BGP 100, distance 200, metric 0. Type internal. And notice it says 155.102 from 155.1.0.1. So that's interesting. Let's look at that. So here I'm saying this is known via router 1. So it's one thing to learn the route, right? So we are learning the routes, but what is our next hop? Like, what does it tell us as far as, for example, does this mean from router 8? Well, let's look at router 4. So how does router 8 learn router 4's loopback? First of all, router 4 is going to, actually we've got a full mesh. So what's going to happen is router 4 is also going to advertise this to the other clients directly. What is the next hop on this guy? Or 4.4. See, notice all these are going to be from 15101, aren't they? Even like 7. Yeah. So if we trace route, okay, but the interesting thing is we're not going through router 1. We just learn it from router 1. So how does it recurse that? Show iBGP. Okay, here's our next hop. Notice we've got valid, best, I for internal. And the next hop is what he advertised to router 1, which is 146.4. But that's not the route we take. Yeah, I'm not sure exactly how this routing is working, because if I do, let's do show IP CEF 150.1.4.4. Okay, that makes sense. Let's look at router 5 though. Show IP route 150.1.4.4. Okay, that's probably because yeah, so it's still when 4 sends us to 1, what's his next hop? It's this interface right here. So when router 5 gets it, he's saying that this segment is the next hop. So why is he going this way to get there? That's what I'm not sure I understand. Show. That's the shortest path. I just don't know how he is calculating that. Yeah, next hop, 155, 146.4. So how does that work? I'm a little baffled by that. Maybe that's covered in another section. I'm not going to go too much to the rabbit hole now. What this lab is focused on is the distribution of the prefixes, right, via iBGP, which is happening. What I do want to look at is, let's do some packet capture on router 5. Select him. Let's just see what this looks like. And I'm going to take away BGP first. You can just do it here. Yeah, let's just take it out as well. Router 1. It's okay, we'll put it back. But let's start this capture. And we'll put it back. First we'll do router 1. Then we'll put back router 5 here. This come up pretty quickly. What I'm curious to see is whether we are getting client-to-client reflection. All right, while that's capturing and converging, etc., let's do our iBGP peerings. So first we need to advertise the peerings into iGRP, right? So we're going to say, let's look at what's configured there now. Okay, yeah, we just need to add that in there. Network 151.79. And we need to do, let's see, router 8, we need to do the same. We're going to say network 155.1. Router 8 to 10, 108.8. It's our link between router 8 and 10. EGP peerings directly connecting router 9 and 10 are in AS54. All prefixes learned from AS54. I guess we need to put this back in. Let's just look at it. So we've even got another interface in here. Yeah, it looks like there's an interface going here. So yeah, let's put it back. This is done with intent. Here's. So we're going to say on router 9. And router 10. I probably shouldn't have doubted it, but I don't know. It just, normally they make you configure all this, which is weird because it's also pairing with router 2. And that's not on router 2, so that's not even going to work. But we're going to pair with router 8. Yeah. And we're going to learn all these different addresses, right? Okay. So that should give us full reachability. That should give us what we want. Let's just see. We're going to put this in router 9. And we're going to put this in router 10. Okay, we'll see if the neighbors come. We probably have to configure this over here, though, don't we? Yeah. So we have to do 7, 9. If, say, let's see, neighbor, oh, directly connected to links. This would be 155.1.79.9 remote AS54. Is that configured over here in router 9? Yeah, it is. And then over here, we got to connect to .1.108.10 remote AS54. Yeah. Okay, so we'll put this in router 7. And this on router 8. Also does our ERGRP stuff. All right, so we should see the neighbor come up. Yep. 10 came up there and 9 came up here. So now let's test. Let's pick a router over here. And whoa. In critical region. BGP IO. I have no idea what that was. Huh, it didn't like something. Oh well. All right, so now if we do our TCL script, or let's just do, yeah, let's do TCL script. For each bar, .150.1.1.1. What's it asking? Yeah, we already did this. We want to see about these prefixes learned from AS54, which are going to be several here. Let's look at router 9, or well, router 7, his neighbor. Show IP BGP. Yes, there's a lot of them in here. Here's all the loopbacks. 112.0.0.0. What's an odd number? It's valid. Yeah, so let's go inside here. Ping. What I said was these. So let's do that as a TCL script here. 112.0.0.0. And what else? Oh, how about from router 10? What is he advertising? We've got it here. Oh, he's got these. Okay. This one. This one. And ping source L0, right? Let's see if I get this right. Let's go to router 1. Looks good. Router 2. Can we do this? Seems like I tried that before and it didn't work. Yeah. Nice. All right, so I don't fully understand the route recursion process yet. It could be that this is going to explain it. I think I may be getting ahead of myself. But yeah, it looks like we're all set here. Let me look at the lab answers. Yep. That looks correct. All the other routers look correct. Yeah, it's correct. Okay. So what's interesting here is let's look at router 1. Show iBGP neighbor 5.1.13.3 advertised routes. Yeah, so look at everything we're advertising. We've got all these that go through AS54, and then we have these internals, which are the loopbacks. We're even advertising this back to himself. That's what we do, right? We're a reflector, but of course, router 3 is going to disregard that route because it has a route for that. But notice the next hop. So he is sending, we were looking at router 4, right? So notice that he is sending 150.1.4.4's loopback, and he's advertising the next hop that he learned, which of course is 146.4. It's this segment here. That's where he learned it, so that's the next hop for router 1 that he sends over to router. Let's look at what he sends to router 5. Should be the same thing. 1.0.5. Yeah, that's his next hop. So then notice too though, let's go to router 5. Show iBGP 150.1.4.4. And notice we've got the originator, and there's a cluster list. So this is saying, I'm in a cluster, and I'm learned this from 155.1.0.1. Has one available, best number 1, table default. Not advertised to any peer. Origin IGP, metric 0. Notice the metric here though. Is that his metric to forward at 146.4? Okay, so what he's doing is he does a recursive lookup to this, show IP route. 15.101.46.4. Ah, okay. So he is getting it from recursion. He's saying here's my route to this segment. And the best way to get there is this as your next hop. And the metric for that is 3072. So that's why we see this. Okay, that explains it. Cool. And then the trace route. All right, good deal. You know, this is not as complicated as I thought it would be to configure. I guess we did not have to use this because we don't actually have this client configured. What if we did? Let's do that for fun. This will be the last thing we do in this lab, I think. Let's go to router 4 and let's just break some stuff. Say router BGP 100, neighbor 15.1.45.5, remote AS 100. And then let's go to router 5, neighbor I'm curious, does that break anything? Show IP BGP neighbor. Well, we got to see it come up, right? We have to wait for the TCP handshake. There we go. Now he's up. So show IP BGP neighbor. Advertised routes. Okay, so he does advertise his loopback. He does advertise his loopback, but if we look over here, okay, so this works like normal iBGP relationship, right? Show IP, show BGP, awesome. Okay, so he does learn the prefix from him, and he prefers it, right? Show IP BGP 150.1.5.5. Interesting. So does he... Now he's not advertising this to any peer. But you can only use one in BGP, right? And as we see, it has chosen to use... Yeah, we only have one. We can't do equal cost multipath by default. So he's probably choosing the best metric through recursion. But what if we do this? What if we use this command? Router BGP 100, no BGP client to client reflection. Which we don't really need. But if we want to cut down on the unnecessary, obviously it's sending those route, it's going to take that route anyway. There's no reason for there to be a peering relationship that I can think of. And there's no need for, at least in this topology, no need for him to sending those additional advertisements. So I wonder if that turns that off now. It does not. Not yet anyway. I wonder if we have to clear it for it to do that. Clear IP BGP 155.145.4. Administrator reset. Now it's back up. Now if we do... Okay, it is still appears to be advertising it. Huh. Interesting. Well, this was not in this lab, but we'll probably come back to that and play with it some. Again, this is my first route reflector lab ever. BGP route reflector. We've met all the requirements. We did it correctly. I think we're all set. Guys, I'm probably going to wrap it up there. I've got so much reading and videos to watch. I would love to lab some more, but got to get into that. So a lot of my time is going to be devoted to that. Thanks for sticking here in the stream. We had a few little stream issues in the beginning, but thanks for sticking in, and we will see you back in the lab tomorrow night. Have a great evening, guys and gals.